Have you ever stopped to think about what's really powering India's progress? I mean, everything, from the blazing lights of Mumbai to the metro trains in Delhi and all the factories driving our economy, it all runs on this hidden, invisible pulse. It's this silent force that keeps everything moving. But what if I told you that this whole continent-sized operation, with all of its incredible complexity, is held together by just one single precise number? A number that, if it even wavers slightly, could bring the entire country to a grinding halt.
That number is 50 hertz. Yep, that's it. This is the very heartbeat of India's national power grid. It might not sound like much, but it is, without a doubt, the single most critical number keeping our nation powered up and moving forward.
So what exactly is this 50 hertz heartbeat? I mean, it's not just some random number they picked out of a hat. It's a fundamental principle of how our electricity actually works. So let's break it down.
Okay, so the electricity in your walls, it's called alternating current, or AC. Now, you might think of it as a steady river, but it's actually more like a tide that flows back and forth really, really fast. Frequency is just the count of how many times that current goes all the way back and forth in one single second. And for India, that magic number is exactly 50.
And get this isn't an accident. It's all about precise engineering. Those giant generators in our power plants, they are calibrated to spin at exactly 3,000 revolutions per minute. It's that specific mechanical speed that creates an electrical current that alternates, you guessed it, precisely 50 times every single second.
You know, a great way to picture this is to think of a dholak player in a band. They provide that steady, perfect beat that every other musician has to follow to stay in sync. Well, 50 hertz is the grid's dholak. It's the rhythm that every single power plant and every appliance across the country has to follow to stay in perfect harmony.
So you might be wondering, why 50 hertz? Why not 60 like they use in the United States? Well, that's actually a piece of history. India inherited the 50 hertz standard from British engineering during the colonial era. And because of that, every single piece of electrical equipment made for India today, from your little phone charger all the way up to a massive industrial motor, is designed specifically to run on this frequency. To change it now would be, well, practically impossible. Now, having everything standardized is a huge strength, but it also creates this incredible challenge. How do you maintain that perfect 50 hertz beat 24/7 across a country as vast and diverse as India? It's a constant, and I mean constant, delicate balancing act.
The best way to think about this balancing act is like a giant, non-stop game of tug-of-war. Every time you flip on a light switch or turn on the AC, you're pulling on one side of the rope, demanding more power. And on the other side, you've got all the generators spinning away, trying to supply exactly enough power to meet that demand. The frequency is the flag in the middle of the rope. It tells you who's winning.
And the stakes in this tug-of-war are unbelievably high. If demand for electricity, that's all of us, is greater than the supply being generated, the generators literally start to slow down, and the frequency falls below 50 hertz. But if there's too much supply and not enough demand, they speed up, and the frequency rises. Both of these scenarios are really, really dangerous for the grid, and the consequences are very real and very costly. When the frequency drops too low, big industrial motors slow down, which can jam up textile looms or make agricultural water pumps less efficient. If it goes too high, those same motors can overspeed and burn out, and all the sensitive electronics in our data centers and hospitals can just get fried.
Now, if that imbalance becomes too great for too long, it can trigger the ultimate nightmare scenario, a cascading failure. That's when a small problem in one area starts to trip other parts of the grid, leading to massive, widespread blackouts, just like the infamous Northern Grid collapse of 2012.
So who stops this from happening every single day? Well, let's meet the guardians of the grid, the incredible people and the amazing technology that are dedicated to keeping that 50 hertz pulse perfectly steady. It's like this high-stakes dance that's happening in milliseconds all the time. Sophisticated systems are constantly watching the frequency. The very moment a tiny dip is detected, an automatic signal shoots out to power plants, telling them, hey, ramp up your output just a little bit. And within moments, the frequency is right back where it belongs, at 50 hertz. And keeping this beat involves a serious team effort. First, you have automated systems. They're called automatic generation control, and they make tiny little micro adjustments every single second. Then you have the human experts at the national and regional load dispatch centers. They're the ones managing the big picture, directing power plants when there are large swings in demand. And how do they see everything? Through advanced monitoring systems that give them a real-time health report of the entire national grid.
Okay, so we've gotten really good at this dance, but just as we've mastered it, a whole new challenge is showing up on the horizon. The fight to maintain 50 hertz is about to enter a brand new era, and it's all being driven by our big push toward renewable energy.
The heart of this new fight comes down to one word: inertia. See, traditional power plants use these massive, heavy, spinning turbines. Their sheer physical momentum, their inertia, acts like a giant shock absorber for the grid, helping to resist sudden changes in frequency. But solar panels and wind turbines, they have zero physical spinning mass connected to the grid. They have no inertia.
So what does that mean? It means that as we add more and more renewable energy, our grid loses its natural shock absorber. That makes it way more vulnerable to rapid frequency changes. The solution? It's going to demand smarter grids, even faster automated controls, and massive energy storage systems, like giant batteries, that can step in instantly to provide stability when the sun isn't shining or the wind isn't blowing.
So, the next time you're near one of those big green transformer boxes and you hear that low, steady hum, just remember, that's not just the sound of electricity. That is the sound of 50 hertz. It's the audible proof of this incredible, nationwide balancing act happening every single second of every single day.
It's the silent pulse that powers our homes, our industries, and our entire future. But as we transition to a greener grid, the ultimate question is still out there. Can India's engineers innovate fast enough to keep this national heartbeat steady? Because keeping that pulse stable, that's what will keep India moving forward.